According to NEC section 250.102b2, when a raceway or armour provides the grounding path for equipment and the raceway or armour is not connected to ground at every joint, a bonding conductor shall be installed around the entire perimeter of the raceway or armour at each joint. In the case of using a metal-clad, abbreviated MC, cable, which is considered a raceway, and the MC cable is feeding a main lug-only panel, which is concentric knockouts, the NEC requires a bonding conductor at each joint in a raceway that provides the grounding path. You are required to use a bonding bushing at one end of the MC cable where it connects to the 200 amp panel. This will ensure that the grounding path is continuous. You do not need to use a bonding bushing at both ends because the other end of the MC cable is connected to the distribution panel, which is already grounded. The bonding bushing should be listed for use with the specific MC cable and panel. The bonding bushing should be installed per the manufacturer's instructions. The grounding conductor in the MC cable should be sized according to the ampacity of the circuit. Considering the specific requirement for bonding bushings with aluminum MC cable and concentric knockouts, understanding the NEC is essential for safe and compliant electrical installations. Concentric knockouts can create a discontinuity in the grounding path, and a bonding bushing ensures a reliable connection to ground. When dealing with a 2500 amp service feeding a main lug-only distribution panel, and then feeding a 200 amp main lug-only panel with 4/0 aluminum MC cable, the primary concern is maintaining a proper grounding path. This is where the bonding bushing becomes critical. The purpose of a bonding bushing is to provide a low impedance path to ground, which is essential for clearing faults quickly and safely. Without this bonding, a fault could create a voltage potential in the metal parts of the electrical system, posing a shock hazard. Firstly, it's important to understand the role of the metal-clad cable. The metal sheath of the MC cable acts as a conduit, providing a path for fault current to return to the source. If this path is interrupted by concentric knockouts, a bonding bushing is necessary to bridge the gap. Secondly, concentric knockouts are designed with multiple removable rings to accommodate different conduit sizes. However, these rings can leave gaps that compromise the electrical continuity of the enclosure. The bonding bushing provides a secure connection to the enclosure, ensuring that the grounding path remains intact. Thirdly, the NEC mandates bonding for systems where the raceway or armour serves as the grounding path, especially when the raceway is not connected to ground at every joint. This is explicitly covered in section 250.102b2, which emphasizes the necessity of a bonding conductor at each joint where the raceway provides the grounding path. Using a bonding bushing at the point where the MC cable enters the 200 amp panel addresses this requirement by creating a direct connection between the cable armour and the panel enclosure. One must consider the installation guidelines. The bonding bushing must be properly sized for the MC cable and the knockout size. It should be installed tightly to ensure a good electrical connection. Additionally, the bonding jumper, which connects the bushing to the grounding busbar in the panel, must be of the correct size as specified by the NEC table 250.102 cone. It's important to note that aluminum MC cable requires specific considerations. Aluminum is more susceptible to corrosion than copper, so all connections must be made with compatible materials and listed for use with aluminum conductors. Antioxidant compounds should be used to prevent corrosion at the connection points. Grounding is a critical aspect of electrical safety and compliance. It ensures that fault currents are safely conducted back to the source, tripping circuit breakers and preventing electrical shock hazards. A properly installed bonding bushing is a small component that plays a vital role in maintaining a safe and effective grounding system. Therefore, in this scenario, a bonding bushing is required at the end of the MC cable where it enters the 200 amp panel with concentric knockouts. The other end, which is connected to the distribution panel, is already grounded, so an additional bushing is not needed there. Ensure that the bonding bushing is listed for use with MC cable installed according to the manufacturer's instructions, and that the grounding conductor in the MC cable is appropriately sized for the circuit's ampacity. Always consult the latest edition of the NEC and local electrical codes for the most accurate and up-to-date requirement. Correctly addressing grounding requirements like this is crucial for ensuring the safety and reliability of electrical systems. It's always advisable to consult with a qualified electrician or electrical engineer to ensure compliance with all applicable codes and standards. This will not only ensure safety but also help in avoiding potential issues with inspections and insurance. Moreover, understanding the fundamental principles behind these requirements can empower individuals to make informed decisions about their electrical systems. Grounding isn't just about meeting code, it's about protecting people and property from electrical hazards. Firstly, the selection of the appropriate bonding bushing is crucial. Bonding bushings come in various sizes and types, each designed for specific applications. The bushing must be compatible with the size of the knockout in the electrical panel and the diameter of the NEC cable. Using the wrong size can lead to a loose connection, which defeats the purpose of the bonding. Secondly, the installation process should be meticulous. Before installing the bonding bushing, ensure that the surfaces are clean and free of any corrosion or debris. Apply an antioxidant compound to the threads of the bushing to prevent future corrosion, especially when working with aluminum components. Tighten the bushing securely to ensure solid electrical connection. Thirdly, the size of the bonding jumper is a critical consideration. The bonding jumper connects the bonding bushing to the grounding busbar within the electrical panel. The size of this jumper must be adequate to handle the potential fault current. Refer to NEC Table 250.102 cone to determine the appropriate size of the bonding jumper based on the size of the ungrounded conductors in the circuit. Ignoring this requirement can result in the bonding jumper overheating and failing during a fault, compromising the entire grounding system. One must know that grounding and bonding are two distinct but related concepts. Grounding refers to connecting the electrical system to the earth, providing a reference point for voltage. Bonding, on the other hand, refers to connecting all non-current carrying metal parts of the electrical system together to create a low impedance path for fault current. The bonding bushing plays a key role in the bonding process by ensuring electrical continuity between the NEC cable armor and the electrical panel enclosure. Understanding the difference between grounding and bonding is crucial for designing and installing safe and effective electrical systems. In the context of using aluminum NEC cable, special attention should be paid to compatibility. Aluminum is a good conductor of electricity, but it is also prone to corrosion, especially when in contact with dissimilar metals. Therefore, when using aluminum NEC cable, ensure that all connectors, bushings, and other hardware are listed for use with aluminum conductors. Also, apply an antioxidant compound to all connections to prevent corrosion. Additionally, consider the environmental conditions in which the electrical system will be operating. In damp or corrosive environments, additional measures may be necessary to protect the connections from corrosion. This may include using corrosion-resistant hardware, applying protective coatings, or even using a different type of cable altogether. Finally, it's important to remember that electrical codes and standards are constantly evolving. Stay up to date with the latest edition of the NEC and any local amendments to ensure that your electrical installations are safe and compliant. Consider attending continuing education courses or consulting with a qualified electrician to stay informed of any changes to the code. It is important to properly torque all connections. Over-tightening can damage the components, while under-tightening can result in a loose connection. Use a calibrated torque wrench to ensure that all connections are tightened to the manufacturer's specifications. Keeping a record of all electrical work performed, including the materials used, the installation procedures, and any test results. This documentation can be helpful for future maintenance, troubleshooting, and inspections. Remember that electrical work can be dangerous, and it should only be performed by qualified individuals who are familiar with the relevant codes and standards. If unsure about any aspect of an electrical installation, consult with a qualified electrician. Firstly, always energize the circuit before working on any electrical equipment. Verify that the circuit is de-energized using a reliable voltage tester. Tag out the circuit breaker to prevent accidental re-energization. Secondly, wear appropriate personal protective equipment, including safety glasses, gloves, and insulated tools. Thirdly, never work alone. Always have someone nearby who can assist in case of an emergency. Ensure that the work area is well lit and free of obstructions. Use proper lifting techniques to avoid strains and injuries. Always follow the manufacturer's instructions when installing electrical equipment. Do not attempt to modify or alter any electrical equipment. Report any unsafe conditions to the appropriate authorities. The grounding system plays a crucial role in electrical safety, providing a path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock hazards. Grounding also helps to stabilize the voltage in the electrical system, reducing the risk of voltage surges and other electrical disturbances. Properly designed and installed grounding systems are essential for protecting people and property from electrical hazards. The equipment grounding conductor is the conductor that connects the non-current carrying metal parts of electrical equipment to the grounding system. The equipment grounding conductor provides a path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock hazards. The equipment grounding conductor must be sized according to the size of the overcurrent protection device in the circuit. The grounding electrode conductor connects the grounding system to the earth. The grounding electrode conductor must be sized according to the size of the service entrance conductors. The grounding electrode conductor must be connected to a grounding electrode, such as a ground rod, a ground plate, or a metal water pipe. Bonding ensures that all non-current carrying metal parts of the electrical system are electrically connected together, creating a low impedance path for fault current. Bonding reduces the risk of electrical shock by ensuring that all metal parts are at the same potential. Bonding also helps to reduce the risk of fire by providing a path for fault current to quickly trip the circuit breaker. A bonding jumper is a conductor that is used to connect two or more metal parts of the electrical system together. Bonding jumpers are used to bond metal enclosures, metal conduits, and other metal parts. Bonding jumpers must be sized according to the size of the circuit conductors. The main bonding jumper connects the grounded conductor to the equipment grounding conductor at the service entrance. The main bonding jumper ensures that the grounded conductor and the equipment grounding conductor are at the same potential. The supply side bonding jumper connects the grounded conductor to the equipment grounding conductor at a separately derived system such as a generator or a transformer. The supply side bonding jumper ensures that the grounded conductor and the equipment grounding conductor are at the same potential. It is imperative that all electrical connections are tight and secure. Loose connections can cause overheating, arcing, and even fires. Use a torque wrench to tighten all connections to the manufacturer's specifications. Inspect all electrical connections regularly to ensure that they are tight and secure. Replace any damaged or corroded connectors. Consider the use of surge protection devices. Surge protection devices protect electrical equipment from voltage surges caused by lightning, power outages, and other electrical disturbances. Surge protection devices should be installed at the service entrance and at any sensitive electrical equipment. Consider the use of ground fault circuit interrupters, abbreviated GFCIs. Ground fault circuit interrupters protect people from electrical shock by detecting ground faults and interrupting the circuit. Ground fault circuit interrupters are required in wet locations such as bathrooms, kitchens, and outdoor areas. A qualified electrician should be used to install and maintain all electrical equipment. Only qualified electricians have the knowledge and experience to safely and properly install and maintain electrical equipment. Obtain the required permits for all electrical work. Electrical permits ensure that the electrical work is inspected by a qualified electrical inspector to ensure that it meets the requirements of the electrical code. Always follow all applicable electrical codes and standards. Electrical codes and standards are designed to ensure the safety of electrical installations.